All right, we've got one more of these equations of this type where we're solving for y, and then we are finding the value of y for each of the values of x that they give us. The equation is 5x equals negative 4y plus 4, and the values they want us to test or plug in are x equals 1, x equals 2, and x equals 3. So let's look at the equation and see what's the first thing we need to do. We need to solve for y. So what's happening right now? Well, besides the fact that it's being multiplied by negative 4, we also have 4 being added to it, and that's the first thing we need to undo. So you have to subtract 4 from both sides. So what we do is we write what's already there, 5x minus 4, equals negative 4y plus 4, what's already there, minus 4. The thing that you're doing to it, the take away 4, is at the end. Okay, and we simplify it. These two simplify out to leave just 5x minus 4 equals negative 4y. Now we need to go the next step and say what's happening to y now. And what's happening to y now is that it's being multiplied by negative 4. So how do we undo that? We undo that with a divided by negative 4. Do that to both sides. Okay? And then when we simplify it out, we get 5x minus 4 over negative 4 equals y. And again, as I said earlier, it's possible to put that negative 4 as a denominator on each of these terms separately. You could get 5x over negative 4 and negative 4 over negative 4, which would work out to be plus 1. But since we're substituting values in, there's no real use in doing that because we're just going to plug in a number here and then simplify it out to a single number anyway. So this is what we're going to continue. This is what we're going to keep right now as our solution, our equation written in terms of y. Okay? So now we're going to take that and we're going to plug it in. Here we write first the equation solved for y without doing anything to it. We start that way. And then on the second line, we replace x with the parentheses and the value that we're plugging in. The first value we're plugging in up top is 1. So 5 times 1, 5, minus 4 over negative 4 equals y. And we can simplify that to say 5 minus 4 is 1. So 1 over negative 4 equals y. Again, the negative can go anywhere, top, bottom, or sitting out front of the fraction. But that's a good solution, so I'm going to box it. And let's do it again. Let's take that equation solved for y, 5x minus 4 over negative 4 equals y. And we are going to replace it with now 2. So 5 times 2 minus 4 over negative 4 equals y. 5 times 2 is 10. So 10 minus 4 over negative 4 equals y. And what's 10 minus 4? It is 6. So we've got 6 over negative 4 equals y. Now, we can't be done with this yet because both of these values, 6 and negative 4, are multiples of 2, and so we can divide them by 2. And so when we do that, we get, and notice what I've done, I've moved, since I was doing that anyway, I moved the negative up to the top. Doesn't make a difference. It could have been 3 over negative 2 or negative 3 over 2. It's the same. Okay? Equals y. And that is it, solved after plugging in the value of 2. One more time we're going to do it. We could take 5x minus 4 over negative 4 equals y, and now we're plugging in 3. So we say 5 times 3 minus 4 over negative 4 equals y, and 5 times 3 is 15, so we got 15 minus 4 over negative 4 equals y. And what is 15 minus 4? It is 11. So we've got now 11 over negative 4 equals y. And I'm going to box that. And we're done.